Thank you all for your interest in our project, focusing on the topic of self-tracking and self-reflection. The paper I'm going to present today is exploring the effectiveness of time-lapse screen recordings for self-reflection in work context. Here is the slide for the outline of today's presentation. Next, I will introduce the background knowledge of this project briefly. Personal informatics refer to tools and methods that can help individuals track personal information for the purpose of self-tracking and self-reflection. As the development of sensors, smart devices, and multiple applications, users can utilize different methods to track their personal data, such as sleep quality, health data, working hours, and etc. With the help of various personal informatics tools, users are able to gain self-awareness easily from their past experience, such as text summary, graphs, and visualizations. After collecting data finished by personal informatics, users would be able to conduct self-reflection for turning insights gained from data into behavioral or perceptual changes. For example, by using a fitness tracking app to monitor daily exercise routines and sleep patterns, individuals can reflect on their lifestyle choices and make adjustments to improve overall well-being. However, pointed out by this paper, individuals are still facing several challenges that can hinder the effectiveness of self-reflection. Here, one common challenge in self-reflection is the lack of contextual information. While data can well summarize what happened, it does not reveal why and how it happened. This is particularly challenging for personal informatics tools in the context of productivity. Suppose this graph is a screen time summary from a month ago. One can know that the working hours have increased from Monday to Thursday, but it will be difficult to understand why it happened. Was there a deadline on Thursday, or was I rather less productive earlier that week for some reasons? For this challenge, it would be helpful for supplement contextual information with personal informatics tool for more effective self-reflection. Our previous studies found that knowledge workers can benefit from visual information along with metadata from their past computer activities to empower knowledge workers to increase their working productivity. In these studies, we took advantages of screenshots to record past computer activities. Through these studies, we found that screenshots offer a rich information about the context of tasks, and users can easily reconstruct mental context about their previous computing tasks, facilitating task resumption and resource management. A history of screenshot can turn into a time-lapse video. A time-lapse video is created by taking pictures at regular interval over an extended period, which are then condensed into a short clip. Here are two examples of time-lapse video: flower blossom and sunset. This type of video can be easily generated by taking fewer photos and take less storage space than taking a general screen recording. Especially for long-term activities, this video can provide users how things changed easily with less time spending on watching. We assume this type of media can facilitate the procedure of recovering past behaviors and encourage effective self-reflection. For example, from these screenshots on the right side, workers can easily identify what they were doing in the past with rich context information. Therefore, applying time-lapse video composed by screenshots of computer screen can be a solution to prompt the process of self-reflection in working context. We take advantages of the pros of this type of video, like visual cues, time and storage saving, and it is easy to differentiate past complicated computer activities. So, in this study, we set out to answer the following two research questions. The first one, to what extent does watching time-lapse video of past computing activities affect workers' productivity and the video's perceived values for self-reflection? Second, how does watching time-lapse video of past computing activities facilitate the self-reflection process for modern knowledge workers? We compared time-lapse video with a traditional productivity tool that can track computer screen activity. For baseline condition, we use rescue time that can record how much time users have spent on different applications and websites. And this application can provide users with visualization to help them understand and interpret past activities. For time-lapse video, we developed an application that can generate a daily time-lapse video at the end of each day, which capture a computer screenshots periodically with customized time interval. We use this application to create daily time-lapse video for users to review their past activities. To answer the research questions, we conducted a 4-week-long field study and compared the effectiveness of time-lapse video and traditional productivity application, which is rescue time, and we choose rescue time as our baseline conditions. Here is the graph that illustrates the procedure of the user study. For the user study, we recruited 15 participant knowledge workers through university mailing list, Prolific, and social media. We had 15 participants with the average age of 27. On average, these participants use their computers for working tasks with around 7 hours per day, and they also spend 3 hours on other activities. To quantify the effectiveness of time-lapse video for self-reflection, we analyzed 3 types of quantitative data: productivity pulse, perceived productivity, and perceived effectiveness. Productivity pulse was a benchmark score calculated by rescue time to indicate the overall productivity based on their daily computing tasks. Perceived productivity and perceived effectiveness are 2 self-evaluate values by participant via a daily survey. As for the qualitative part, we conducted thematic analysis on data collected from daily questionnaires and a semi-structured interview. Here are the quantitative results to answer the first research question. In the first graph, we find there was no significant difference in their productivity measured in rescue time. On the second graph, however, their perceived productivity was higher when they used time-lapse video, and the difference was statistically significant. This means that participants felt more productive when they review time-lapse video than when they review the rescue time summary. In the third graph, the participants find that time-lapse video to be more effective than rescue time. The difference was statistically significant. Next, we checked if there is any learning effects during the 4-week study. In the first graph, we found that on average, productivity measured by rescue time actually went up in the second 2 weeks, regardless what they used compared to the first 2 weeks. The difference was statistically significant as shown. In the second graph figure and third figure, similarly, participants perceived productivity and perceived effectiveness on the tools that used went up at the second 2 weeks. The difference was also statistically significant. This means that regardless of which tools they used, both their actual and perceived productivity increased during the last half of the study. One could argue that the more they engaged in self-reflection activities, the greater impact they will have on their personal productivity. Another interpretation is that having experience in using both types of tools could have positively impact their working productivity. Next, to better understand the learning effect, we checked if the order in which they run the study mattered. We found that the study order has an interaction effect with which tool they used. Overall, the group who used rescue time initially and used time-lapse video for the second half of the study showed more positive effects in productivity. In the figure 1, for the group which used the rescue time first and time-lapse video for the second half of the study, which we call the RT first group, had more productivity gain, which is denoted by the height of error on the right column. For group which used time-lapse video for the first half of the study, which is denoted as TLV first group, their productivity went up, but not as much as the other groups. For perceived productivity, their productivity gain was more significant when they used time-lapse video after rescue time than when they used the rescue time after the time-lapse video section. In the third graph, similarly, their perceived effectiveness on time-lapse video was also higher when they used time-lapse video later than rescue time. All these results indicated that it is more useful to use time-lapse video after they use rescue time. Next, to answer the second research question, we conducted semantic analysis on qualitative data that collected from participant interview and daily survey. Overall, we found that time-lapse video showed knowledge workers a vivid story about their past activities, not only displaying or visualizing data simply. The first result is that time-lapse video is effective for task-oriented reflection. Users can be reminded with details by specific computing tasks, not general application or resources name. This is because that time-lapse video were more informative, presenting rich details about what they have worked on in the past. In the interview, most participants articulated that they had changed or had inclinations to change their behaviors due to self-reflection under both conditions. Well, the time-lapse video did not offer clear summaries of users' productivity. It is worth mentioning here that participants said screenshots give them effective feedback that motivated or even pushed them to change their behaviors. Along with the self-reflection, time-lapse video is able to foster a sense of achievement and well-being. Instead of only emphasizing the result, time-lapse video can display the process of how participants made progress gradually and clearly. Participant 1 comment showed a good example of how time-lapse video fostered positive reflection. Just like they said, I found that I only read 2 papers, but I was supposed to read 3 based on my yesterday's plan, and this made me feel depressed and demotivated for not being able to finish my work today. Later, when I went back to my videos, I found I was actually doing lots of searching on these papers, related work, and spending more time on understanding their models, math formulas. Now I know I really did something and that's good. Then I stop blaming myself like that. In this way, users can feel the sense of achievement and be proud of themselves, especially for some complicated mental required tasks such as programming, reading, and writing. From the interview, participants also mentioned that via time-lapse video, they were able to notice unknown habits about their working patterns. Like P2 said, they just noticed they might have spent lots of time on their phones because the video frames were not changing for several minutes while they were doing the self-reflection. Now, these are the implications from this study. We found that including visual recordings and associated with related data can facilitate the process of context recovery and self-reflection. This emphasis on contextual information not only foster a deeper understanding, but also encourage positive reflection, ultimately contributing to more impactful self-awareness. What is more, the study indicated that time-lapse video is able to enhance sense-making along with traditional PI tools, such as rescue time. Users prefer different types of data for self-reflection, varied by computing tasks, and solo type of data is not that enough for interpretation. Together with rescue time, understanding quantitative result first can definitely help users to understand contextual information in the time-lapse videos. And in conclusion, here is the summary of our research project. The first one is time-lapse video can foster effective self-reflection. The second one is contextual information available in time-lapse video foster and positive framing in their personal productivity. The third one is combination of multimodal data can be a promising method for personal informatics. And this is all for our project. Please read our full paper for more details. Thank you.